Hi students, let's see in this video what are the operations on sets. Like on numbers we have addition, subtraction, multiplication, division, basic operations. Here on sets also we have some operations. In that first is what? Union. First operation is union, that is A union B. Let's see how to find out A union B. Let us take two sets A and B. A is equal to 1, 2, 3, 4, 5 and B is equal to 4, 5, 6, 7, 8. We have seen the introduction and the different types of sets in the previous video. Now let us see how to find out union, intersection, difference and symmetric difference. These are some basic operations on sets. Let us see how to find out these. Now A union B. Union means what? All together. So here we write all the elements of A and B together in one set. That set will be the set of all those elements of A and B will be called as A union B. So you can list out like this the elements of A union B. You have to write all the elements of A first. 1, 2, 3, 4, 5. You have to list out all the elements of A first. Then when you write the list of elements of B, you have to see 4 is already we have written, so no need to write. You should not write repeated elements in any set. So 4 already we wrote, we should not write now. 5 also we wrote already, so 5 also should not be written. Now remaining elements which are not written till now are 6, 7, 8. So we have to write here 6, 7, 8. So this is what? Set of elements of A union B. So what is A union B? Set of elements of A or elements of B will be called as A union B. In set builder form, A union B can be written like this. What? A union B is equal to X such that X belongs to A or X belongs to B. Means in this we will be having elements of A or elements of B. Elements from A we will be having or elements of B we will be having. That is what A union B. Now let us see what is A intersection B. Intersection means it is a set of common elements of A and B. Set of common elements of A and B. So we have to find out what are the common elements in both the sets. You can see here 4 is there in both the sets as well as 5 is also there in two sets. So what? 4 and 5 are common elements. So in this set A intersection B, what elements we have to write? Common elements, that is 4 comma 5, because in above two sets common elements are 4 comma 5. Yesterday we have seen one types of set, that is what? Disjoint sets. What are disjoint sets? Which do not have any common elements. So when there are no common elements, A intersection B will be empty set. We do not write any common element because we do not have any common elements, that will become empty set. So if given two sets are disjoint sets, A intersection B is empty set. How do we write set builder form of this? A intersection B is equal to X such that X belongs to A, means what? Here X should, that element should be there in A and also in B. So we write X belongs to A and X belongs to B. So if it is present in both the sets, then we say that is there in A intersection B. This is what? Set builder form of A intersection B and the elements of A intersection B. So A union B means we have to write all the elements together in one set. A intersection B means you should write only common elements of A and B in one set. Now let us see what is A minus B. A minus B means here we write the only elements of A but not the elements of B. In this only elements of A but not the elements of B. What are the only elements of A? 1, 2, 3. Why we do not write 4 and 5? Because they are also elements of B. We should not write elements of B. We have to write only elements of A, that is A minus B. A minus B is what? Only 1, 2, 3. How do we write set builder form? A minus B is equal to X such that X belongs to A and x does not belongs to B, means we do not take elements of B. In the previous case, A union B and B union A will be equal. That is, union satisfies commutative property under union. Set satisfies commutative property under union. Even intersection also satisfies commutative property under union. That is what A union B will be equal to B union A. A intersection B will be equal to B intersection A. But A minus B will not be equal to B minus A. B minus A is different. So if you write B minus A, what you have to write only the elements of B. What are the only elements of B? 4 and 5 are also elements of A. 4 and 5 we should not take. Only in B minus A we get only 6, 7, 8. So these are what? Elements of, only elements of B. So this is what? B minus A. Now we can write B minus A in set builder form as x such that x belongs to B and x does not belongs to A. This is what? Set builder form of B minus A. Now let us see what is symmetric difference. Symmetric difference can be written in two ways. One is A union B minus B union A, not B union A, A intersection B. A union B minus A intersection B, or this can also be written as A minus B union B minus A. So you know what elements will come in this? Without, except common elements, remaining all will come. Except common elements, remaining all the elements we have to take. That means what? A intersection B should be subtracted from A union B. So what are the elements without common elements? We will be having 1, 2, 3, and here 6, 7, 8. So if we do not take common elements from the all elements, that will be symmetric difference. We also represent it by A delta B. We also represent it by A delta B. This can also be represented as A delta B. This is what symmetric difference of A union B. So this can be written in set builder form, can be written in two ways. You have to write union of these or difference of A union B and intersection B, or union of A minus B and B minus A. So this is what operations on set. Hope you understood this topic up to here. Now let's see how a set can be represented through a Venn diagram or by a Venn diagram. Now let us take a set A is equal to, let A is equal to some elements 1, 2, 3 elements I have taken in a set. Now this, all these elements can be represented by a closed circle. Let us take a circle. So now this is what? Set A. This circle represents set A, and all the elements of set A we write within the circle like this: 1, 2, 3. So this is what? A Venn diagram representation of a set. Suppose if we have two or more sets, how do we represent? Let us take two sets together. Now how do we represent two sets? Through Venn diagram. Now let us take, let A is equal to P, Q, R, S, and B is equal to R, S, T, U. Like this we have two sets in which these elements are present. How do we represent these two? By using Venn diagram. In this case, what we have to do? We have to draw the two circles and we have to observe, are there any common elements in two sets? Do we have any common elements in two sets? We have to see. So if we observe, we have R and S common elements, so we call them overlapping sets. Whenever there are common elements, we call them overlapping sets. If there are no common elements, we call them disjoint sets. So one more circle we have to take. Two circles, one represents A, other represents B. So here this is A, let us take this is A and this is B. If they are disjoint sets, we have to take the circles such that there is no common element. If they are disjoint sets, circle should be taken like this. If they are overlapping sets, then circle should be taken like this, in which some common region is present. Now, how to write these elements in both the sets? Now, whenever you draw or whenever you represent two sets by using Venn diagram, first we have to fill up common elements in the common region. What are the common elements in these two sets? R, S are the common elements. So this R and S we have to fill up in common region. So here this is the common region. In this common region we have to write R, S. Now when you take A in set A, in this circle already, in circle A already we have written R and S. Now what are the elements that are left? P and Q are left. So that P and Q should be written here. P and Q. Now in set A what we have? P, Q, R, S, in which R, S are common in B also. Now similarly we have to write the elements of B. In B also already we wrote R and S. Now what are left over? T comma U. So T and U should be written within the circle B. So now if you see in P, in A we have PQRS, in B also we have PQRS, in B we have RSTU. In A we have PQRS and in B we have RSTU, and in common we have R and S. All together we have PQRSTU. So this is the representation of two sets together. Now let's see another case. Let A is equal to 1, 2 and B is equal to 1, 2, 3, 4. Now here you can observe every element of A is also present in B. 1 is present in B, 2 is also present in B. So here we can say that A is subset of B. So how do we represent if one set is subset of other set? How to represent the elements when one set is subset of other set? If one set is subset of other set, we have to draw two circles. Let's take this is what A, and one more also we have to draw within A. Okay, A is subset to B, so the smaller circle is A and the outer circle, bigger circle is B, because B is superset and A is subset. Now first we have to write the elements of A. What are the elements of A? 1 and 2. So 1 and 2 should be written within the circle A. Now when we write the elements of B, already 1 and 2 are also there in B. We have written already 1 comma 2 in B and as well as A. Now the remaining elements should be written in B. So what are the remaining elements in B? Those should be out of A. That is what here like this 3, 4. Now if you observe in set B we have 1, 2, 3, 4, but in set A we have 1 and 2. This is the representation of two sets when one set is subset of other set. Hope you got idea about this also. Now after this let's discuss about what is a cardinal number of a set. Very simple concept. Cardinal number means what? It is the number of elements present in the set. For example, in this example if you see in A how many elements are there? 3 elements are there. So we can write n of A is equal to 3. We represent it as number of elements of A. N of A is equal to 3. So what is cardinal number? Simply the number of elements present in the set is called as cardinal number of set. Here in this case if you take n of A, here it is n of A is what? 4. Okay, here n of B is also 4. Here n of A is equal to 2. But here n of B is equal to 4. Hope you got idea about cardinal number. Cardinal number means what? Simply number of elements present in the set is called cardinal number of a set. Thank you. Hello students. Let's discuss today How do we represent sets in Venn diagrams? Hope you all know what are sets. Set is a collection of elements. Well-defined collection of elements will be called as sets. So here, those elements can be numbers or some other objects. This collection of well-defined objects or elements will be called as a set. A set can be denoted in a closed bracket. Elements of the set can be represented within the closed brackets, like A is equal to A, B, C, like this. So now these elements can also be represented by Venn diagrams. So this is very interesting and important topic also. Even in your competitive exams, reasoning based also this type of questions can be asked. Means Venn diagrams related questions can be asked. So let's see how do we represent elements of a set through a Venn diagram. Here we can see in the figure, uh, we have two circles. One is denoted by A and other is denoted by B. One is circle A and other is circle B. So elements of a set can be represented in a closed figure, that can be circle or ellipse. So here one set I represented by the circle A and other set I represented by circle B. So here, if you want to see, if you want to write down what are the elements of A, elements of B, and some other operations on sets and sets A and B, let's see now how to write these all. Now first let us write what are the elements of A. Here elements of A, you can observe clearly what are the numbers that are present in the circle A will be called as elements of A. For example, here in this you can see this complete circle. These all comes under the elements of A. Let's represent with another one. So another color. So these are the whatever elements are present in this region comes under elements of A. That means what? Which are there under the circle A will be called as elements of A. We can take them as elements of A. So here what are the elements of A? We have 1, 2, 3, 4, 5. So these are the numbers that are present in circle A. So they are what? Elements of A. Now similarly, if we want to write elements of B, you can see what are the elements present in circle B. So these all. So these all comes under in this area. Whatever numbers are present in this area comes under set B. So let's write what are the elements present in set B. That is what? 6, 7, 8, 4, 5. Or you can also write 4, 5, 6, 7, 8. So these, there is no importance to the order of the elements. Any element you can write first, any element, any number you can write first, any number you can write later. There is no importance to the order. So that is what B, elements of B. Now we have written elements of A and elements of B. Then next one important operation we have, that is A union B. What we call it? A union B. What are the elements that are present in A union B? The elements of A or the elements of B. Set of elements of A or elements of B will be written in the set of A union B. So what comes under in A union B? So complete two sets. What all we have elements in both the sets in this region. Whatever elements are present in these both the regions will comes under A union B. So complete region we will take as A union B. So here if we write elements of A union B, what will come in that? All the elements of A and B. So here what? 1, 2, 3, 4, 5, 6, 7. These all are elements of A union B. Now we have one more important operation, that is A intersection B. A intersection B. The symbol A intersection B is denoted by inverted U. Before union was represented by U, now inverted U. This is what we call it as A intersection B. Now what are the elements that are present in A intersection B? Only the elements which are present in common region of two sets. So only the elements present in this region will be called as A intersection B. So the common elements will be only common elements. Set of common elements of A comma B will be called as A intersection B, and here the elements in this example are 4 comma 5. These are the elements of A intersection B. So elements of A we wrote, elements of B we wrote, elements of A union B we wrote, elements of A intersection B also we wrote. Now we have one more important operation, that is A minus B. What are the elements in A minus B? These are the elements only present in A but not B. So you should take the elements of A but not the elements of B. So what? Only the elements present in A up to here only. Why we will not take 4 and 5? Because they are also present in B. So how do we get A minus B? We have to subtract the elements of B. We have to remove the elements of B and also common elements of A and B. Both should be removed. That means we should take only the elements of A but not the elements of B will be taken as A minus B. So here element, what are A minus B? What are the elements present in A minus B? 1, 2, 3. Only these three will comes under A minus B. Now you can tell me what are the elements of B minus A. That is because we wrote already A minus B. You can guess what are the elements present in B minus A. Yes, the elements which are present only in B but not A. So here also we will not take common elements. Only these elements, the elements present in this region will be taken as B minus A. So here what will come? Only 6, 7, 8. These are what? B minus A. So A union B, A intersection B, A minus B, B minus A. Very important operations. And from by using Venn diagrams, we can collect the elements of these sets in this way. Now one more important operation is also there, that is called symmetric difference of A and B. We denote symmetric difference of A and B in this way: A delta B. We read it as A delta B. How can we find A delta B? The elements of A delta B are the elements of A minus B, means only this region you have to take, and the elements of B minus A, only this region together. We will not take elements of A intersection. This is what common element. Except common elements, remaining all the elements we will take in symmetric difference of A comma B. Hope you understood this one also. So what are the elements comes under A minus B? Elements comes under A minus B are only 1, 2, 3, 6, 7, 8. So these are what? A delta B, elements of A delta B. Hope you understood this. In the next video we will discuss more deep about it. Thank you.